Imagine that the world we live in is three-dimensional: length, width, and height. We move within these three dimensions: right and left, forward and backward, up and down. That's why birds can fly, why there are stairs to move upward and downward, and why in basketball the ball was thrown into a hoop. But pause for a moment and think, is this really freedom? Or are we simply moving only as much as these three dimensions allow us to? As children, many of us have wondered about this. Why can't I fly? Why can't I pass through a wall to the other side? The answer is actually very simple, because we live in a three-dimensional world, and we are bound by the rules of this world. But there is an important point here. These rules are not the absolute laws of the universe. They are simply the rules of the dimension we inhabit. In other words, if other dimensions existed, our movements could be completely different. In this video, we will talk precisely about this topic: higher dimensions. But don't worry, this is not a math lesson. It's a journey into the idea that reality may be far stranger than we imagine. If you subscribe to the channel to continue watching the video, I'd really appreciate it. Now imagine that you are a completely flat being, living on a sheet of paper. Let your name be Flatlander. You can move only left and right, forward and backward. In your world, there is no such thing as up or down. For Flatlander, the world is made entirely of lines. He sees other beings as lines as well. Houses are lines, trees are lines, everything is a line, because he can only see the edges of things that lie on the surface he lives on. Now imagine that someone places a sphere onto this flat world. Flatlander would not see it as a sphere, but merely as a circle. He would never be able to see its interior, its volume, or its true shape. If the sphere were to pass through his world, Flatlander would witness something like this. A circle suddenly appears, grows larger, then shrinks and disappears, and he would never fully understand what it truly was. Now we come to the most interesting part. Imagine that you are looking at Flatlander from above. You can see his entire world at once. Even if he is inside a closed room, you can see its interior. Because for you, his walls are not obstacles. They are just lines, and you are observing from another dimension. Even more fascinating, you can take Flatlander out of his world and place him somewhere else, without passing through any walls. You simply lift him upward and then put him down in another location. To Flatlander, this would be magic. One moment he is in one place, and the next moment he is suddenly teleported somewhere else. This is exactly what would happen to us, just one dimension higher. And now we reach the truly intriguing, perhaps even slightly terrifying part. Mathematicians and physicists say that a fourth spatial dimension is possible. Some even talk about 5, 10, or 11 dimensions. But for now, the fourth dimension is more than enough for us.
So what does the fourth dimension look like? The answer is this: we cannot see it. It is physically impossible, because our brains are built to understand only three dimensions. We have three-dimensional eyes, we live in a three-dimensional world, and we are three-dimensional beings. Imagining anything beyond that is extremely difficult for our minds. People have tried to grasp this before. In 1884, Edwin Abbott wrote a book called Flatland. In that book, he described beings living in a flat, two-dimensional world and showed that they could never fully understand three-dimensional objects. The point was this: it is completely normal that we cannot understand the fourth dimension either. But when it comes to mathematics, the situation changes. Mathematics doesn't need to see, it can calculate. For example, there is a concept called a hypercube. This is the four-dimensional version of an ordinary cube. Let's understand this in a simple way. First, there is a point. When you extend a point in one direction, you get a line. When you extend the line in another direction, you get a square. When you extend the square in yet another direction, you get a cube. Now comes the strange part. We extend the cube in one more direction, But this direction does not exist in our world. We cannot see it or feel it, yet in mathematics this direction does exist, and the result is a hypercube. A hypercube has 16 vertices and 32 edges. Can you imagine it? No, neither can I. No one can, because we live in 3 dimensions. But computers can calculate it. Mathematics can describe it. And the strangest part of all is this: it exists mathematically. So how can we see it? Only through its projection. Just as a cube casts a 2-dimensional shadow on paper, a hypercube casts a 3-dimensional shadow. And that shadow, so to speak, completely blows our minds.
Now we've reached the truly frightening part. In higher dimensions, mathematics becomes so strange that it defies human intuition. And this is not just theoretical entertainment. It tells us something about the very structure of reality. The first horror: spheres disappear. In 3 dimensions, we more or less understand how much space a sphere occupies, right? But as the number of dimensions increases, something very strange happens. Imagine placing the largest possible sphere inside a large cube. In 2 dimensions, a circle inside a square, the circle occupies about 78% of the area. In 3 dimensions, a sphere inside a cube, this drops to 52%. The decline has already begun. In 4 dimensions, 31%. In 5 dimensions, 16%. In 8 dimensions, just 2%. In 10 dimensions, 0.2%. In 21 dimensions, 0.00001%. So what's going on? In higher dimensions, the sphere practically disappears. Inside the cube, it occupies almost no space at all. And now comes the most terrifying thought. Almost the entire volume of the cube is concentrated in the corners. Yes, the volume is in the corners. This makes no sense to our intuition. Our 3-dimensional brains rebel against it. But mathematics says it's true. And this is not just a theoretical game. This is a real effect in high-dimensional systems. The second horror: the concept of distance collapses. In 3 dimensions, distance is simple. There are 2 points, and we can calculate the distance between them. There's near, far, and somewhere in between. But as the number of dimensions increases, this concept begins to break down. Imagine choosing 2 random points. In 3 dimensions, distances vary. In 10 dimensions, distances become very close to one another. In 50 dimensions, almost all points are at the same distance. In 100 dimensions, all of them. How is this possible? Because in higher dimensions, space becomes so vast that randomly chosen points almost always end up near the edges of the space. In the distance between those edges, it is almost always the same. The conclusion is deeply unsettling. In higher dimensions, the ideas of near and far lose their meaning. Everything is far, and everything is equally far. The third horror: volume is not in the center. Think of an orange. In 3 dimensions, the peel is thin, and most of the mass lies in the center. But in higher dimensions, this is completely reversed. In a high-dimensional sphere, almost all of the volume lies in a thin layer near the surface. In 10 dimensions, more than 99% of the volume is in the outer 10% of the radius. In 100 dimensions, almost the entire volume is in a layer infinitesimally close to the surface. So what's happening? There is almost nothing at the center. This destroys all of our intuition, but this is a fixed, fundamental rule of high-dimensional geometry. The fourth horror: things get compressed in a very strange way. Another mind-bending phenomenon appears in higher dimensions. Imagine placing several small spheres inside a cube. Now you want to place one large sphere that touches all of these smaller spheres at the same time. In 3 dimensions, this problem is simple. The large sphere exists and fits inside the cube. Everything makes sense. But as the number of dimensions increases, the situation changes completely. In higher dimensions, this large central sphere does not fit inside the cube. Yes, the sphere that touches all the smaller spheres actually extends outside the cube. How is this possible? The reason is this. In higher dimensions, space is not filled the way we imagine it. Between the corners of a cube, there are extra directions that we cannot see or feel, and the large sphere expands precisely along those directions. Something that should be inside the cube for us is in fact outside of it in other dimensions. This means that in higher dimensions, the center is no longer a safe place. The ideas of inside and outside become blurred. Space itself deceives us. And this is not just a mathematical trick. This is the normal behavior of high-dimensional reality. Now you're probably thinking, okay, this is interesting, but what does this have to do with me? The short answer, a lot. Because these strange, mind-defying high-dimensional spaces are already at work in real life, and we use them every single day without even realizing it. Artificial intelligence and machine learning operate precisely in high-dimensional spaces, on your phone, on social media, in search engines, everywhere. Take facial recognition, for example. When you upload a photo to Facebook or your phone, the computer doesn't see it as just an image. That image is transformed into a point in a space with thousands, even millions of dimensions. Every pixel, every color tone, every shadow, each one is a separate dimension. An image with a resolution of 1000 times 1000 pixels already exists in a space with millions of dimensions. And here's the strangest part. The computer can recognize your face in this completely anti-intuitive alien space. How? Artificial intelligence learns that in high-dimensional space, your face occupies a specific region. When a new image appears, it asks just one question. Is this point inside that region? If the answer is yes, then it's you. And it doesn't stop with faces. Today, machines can recognize people, animals, plants, cars, buildings, all as separate regions in high-dimensional space. So those high-dimensional spaces we just called terrifying, they are already working inside your phone.
How does Google Translate work? The answer, higher dimensions. Google Translate does not translate words like a dictionary does. It places words into a high-dimensional space. Each word is like a point in a space made up of hundreds, even thousands of dimensions. And these points are not placed randomly. They are arranged according to meaning. For example, the word king is close to queen. Words like capital, power, throne are also located nearby. Why? Because these words revolve around the same topic, the same meaning. Artificial intelligence doesn't feel this. It calculates it. Now comes the most surprising part. Words that carry the same meaning in different languages end up in the same regions of high-dimensional space. King, kral, hre, konik. Different languages, different sounds, but the meaning is the same. And because of that, for artificial intelligence, they fall into the same place. How is this possible? Because artificial intelligence discovers structure in high-dimensional space, a structure we cannot see or feel, but one that is real. And it is precisely thanks to this structure that machines understand languages, grasp meaning, and translate. When Netflix recommends a movie to you, what is it doing? Working in high-dimensional space. Each movie is described by hundreds of features: genre, actors, director, mood, pacing, color palette, and more. Each feature is a separate dimension. You, too, are a point in high-dimensional space, defined by the movies you watch, and the system finds movies that are close to you. Spotify uses the same principle. Each song is a point in high-dimensional space, and the system finds songs that are near you. In modern medical imaging, high-dimensional space is especially critical. MRI or CT scans are analyzed in spaces with thousands of dimensions. Artificial intelligence learns where cancerous tissue lies within this high-dimensional space. Then, in new scans, it searches for that same region. This technology already detects certain types of cancer better than doctors. Why? Because it can see high-dimensional patterns that we cannot.
Stock markets? They are high-dimensional systems. Thousands of stocks, each interacting with the others. Every interaction is a separate dimension. Large investment firms use high-dimensional space analysis to assess risk. They identify dangerous regions in high-dimensional space and avoid them. This may even be one reason the 2008 financial crisis could not be predicted. The danger emerged from an unexpected high-dimensional region. Now we arrive at the most frightening theory of all. Some physicists say that our universe may actually have 10 or even 11 dimensions. It's just that these extra dimensions are so small and so tightly curled that we cannot see them. Imagine a garden hose. From far away, it looks like a simple straight line, but when you look closely, you see that there is also a circular dimension wrapped around the hose. An ant can walk forward and backward along the hose. That's the large dimension. But at the same time, it can move around the hose. That's a small, curled dimension. Our universe could be like this. We see only 3 large dimensions, but at every point, down to scales smaller than an atom, there may be additional hidden dimensions. This idea is called string theory. According to this theory, everything in the universe, atoms, electrons, particles of light, is actually made of incredibly tiny strings vibrating, and these vibrations take place in high-dimensional space. Different vibrations create different particles. An electron is one type of vibration, a quark another, and a photon something entirely different. And these vibrations occur precisely in those extra curled-up dimensions that we cannot see. This theory has not yet been fully proven, but many physicists take it seriously because it attempts to unify quantum mechanics and relativity, 2 theories that work well on their own but do not fit together. So what exists in those extra dimensions? No one knows for sure. Maybe parallel universes. Some theories suggest that countless parallel universes exist within these extra dimensions. Every possible event happens in some universe. In one universe, you are reading this text. In another, you wrote it. In a third, you were never born. In a fourth, humans do not exist at all. And all of these universes could be right here, side by side. We just can't see them because our eyes can perceive only 3 dimensions. Maybe there are beings we cannot see. They could be here, all around us, simply living in those extra dimensions, and we would never be able to perceive them. Imagine this. A civilization exists in an extra dimension. They are far more advanced than us. They can observe our universe, study it, perhaps even influence it, but we will never see them because they exist in that dimension. It sounds like science fiction, but physicists working at the very edge of science are discussing these possibilities seriously.
The mind-blowing moment. Let's imagine this in a different way. Picture a 4th-dimensional being. Let's call it Hyperion. If it entered your room, what would you see? First, it wouldn't come through the door. Walls would not be obstacles for it. Just as we can pass over the walls of a circle drawn on paper, Hyperion could pass through your walls. It would simply appear out of nowhere. Second, you wouldn't be able to see it fully. You would only perceive its 3-dimensional cross-section, like a sphere passing through your room. First, a small circle appears, then it grows, then shrinks and disappears. Hyperion would look like that to you, a constantly changing, strange shape. Third, it could touch your internal organs without touching your skin, just as we can reach inside a 2-dimensional being from above. Everything hidden from you would be completely visible to Hyperion. Fourth, it could disappear by moving in a direction you cannot see. It could remove an object from inside a locked box without opening it.
Simply lift it in the fourth dimension, move it, and place it back. Fifth, it could see things you can't. It could read every page of a closed book at once. It could see all the neurons in your brain simultaneously. Nothing hidden from you would be hidden from it. Sixth, it could perform actions that seem impossible to you. For example, it could take your right hand, rotate it in the fourth dimension, and put it back, and your right hand would become a left hand. No mirror, no cuts. Terrifying, isn't it? And now comes the even more frightening part. Maybe Hyperions actually exist, and we will never be able to see them. Maybe they're watching us right now. To them, we are like fish in an aquarium, completely visible, completely exposed, with no secrets at all. The power and the weakness of mathematics. Here lies a strange paradox. Mathematics allows us to describe higher dimensions. We can write formulas, perform calculations, and obtain results. And those results often match what we observe in our three-dimensional world. But there is a problem. We will never truly understand higher dimensions. We will never be able to visualize them, to bring them fully before our eyes. It's like having an ability that exists, but one you can never use. For example, a blind person can explain colors scientifically, wavelength, frequency, physics, but they will never see red. They will never feel it. We are in the same position. We can explain higher dimensions, but we will never see them. And perhaps that is the most frightening part. We are limited. We are trapped inside three dimensions. We cannot step outside them. All of this shakes our understanding of reality. In philosophy, there has long been an ancient question: what is reality? For a long time, we believed that reality is what we see, but higher dimensions show us that what we see is only a tiny fraction of reality. Think of Plato's allegory of the cave. People are chained inside a cave, watching shadows on a wall, and they believe those shadows are reality itself. But the true reality is the objects casting those shadows. We are in a similar situation. We see only the three-dimensional shadows of a higher dimensional reality. And we think that's all there is. But true reality, it lies beyond our understanding. This also changes how we view science. What is the goal of science? To understand reality. But what if reality lies beyond our capacity to perceive it? The answer is simple. We must still keep exploring. Because every small piece of understanding gives us something. It creates new technologies. It expands the boundaries of our thinking. And maybe one day, with new tools, new senses, new ways of thinking, we will find ways to perceive these extra dimensions. In the future, we may create technologies that allow us to see extra dimensions. Bats see with ultrasound. Snakes sense infrared, and we, with instruments, explore parts of the spectrum that are invisible to our eyes. Perhaps we will build similar tools for extra dimensions. Through VR and AR, it may be possible to simulate the fourth dimension. Mathematicians are already creating hypercubes in virtual reality. Users say the experience is indescribable. The brain struggles to process it and feels like it explodes. Maybe evolution could help as well. Future generations might have brains capable of grasping these dimensions, or artificial intelligence, thinking naturally in high-dimensional space, might explain them to us. Higher dimensions show us how much of reality can remain hidden from us. The world we see and touch is only a small part of what exists. We are three-dimensional beings floating in a universe of 4 or more dimensions, yet unable to see our surroundings. The frightening part is that our perception has limits, but that is also what makes it magnificent. The technologies we use every day, facial recognition, Google Translate, Netflix recommendations, medical scanners, all of them are built on high-dimensional mathematics. Perhaps at this very moment, a fourth-dimensional being is standing right next to you, watching you, reading every thought you have, and you will never know. And that is both terrifying and awe-inspiring.
Higher dimensions show us this. There is so much left to discover, so much left to understand. We are simply prisoners of 3 dimensions.